Last time we was discussing about the KG equation. It is called Kelvin-Gordon equation. Okay, and we have stated that phi, which is a scalar field, this phi, which is a scalar field, or I think if I say that is psi or phi, whatever I have said, okay, psi m exponential of minus iota e t minus t dot x. That is also the solution of the Schrodinger wave equation. Okay, this is the solution of Schrodinger wave equation, and this, because this is psi and minus psi m is a amplitude, means constant, and that will be equal to iota minus, they may be right as EP dot TX, because one must be a minus. We may write minus here, or we may write minus here. Okay, that's up to you. Okay, if I write here, okay, when we take dot, then one will be transpose. Okay, dot mean minus iota E P. In concomitant covariant, we will not take Hermitian conjugate, but if we deal in Cauchy space, mean if we are dealing with the in the form of iota, I have already explained in my previous lecture, then I will use the Hermitian conjugate, otherwise I will take a transpose, because one will be covariant, one will be a contravariant. Okay, they may write in the form of this, and this is equal to psi m exponential e minus iota e p and t minus x. Yes, that's this is okay. And if both are positive, this will be, this is for momentum. I have already explained in my previous. This is a for momentum, and this is a, because we are taking it rho. This is okay, and this is because t is positive, x is minus. This is a contrast. Okay, I have already explained it in the, okay, this is contravariant, and row is changing, first row and second. Okay, so for covariant, x component, sorry, here I must write this, and this must write for I must write. Okay. Oh, okay. Psi is alpha is contracting with the alpha. Both are the true tensor indices, and both are contracting. So free indices is, this is indices free, because it is in the this is contracting. Okay, got it? Because this is contracting. Alpha is contracting with the alpha, so this is a Lorentz invariant. So this is it means this implies that psi alpha is under Lorentz transformation psi prime, that will be remain the same. Means after transformation they will be the same. There will be no change. You may write in this way that even if you are applying a Lorentz transformation on psi A, okay, this will not change it. This will remain the same. What is the scalar? That I have already, zero rank tensor will be a scalar and it will transform in a such a way that it will not transform. It will remain the same. Under Lorentz transformation it is not changing. Why it is not changing? This is because it is a Lorentz invariant. So this psi will remain the same. So Lorentz transformation will be not affect on that. Okay. Okay, it is clear. So this is a scalar. But Schrodinger wave equation can't be written in the form of the covariant form. And Schrodinger wave equation is not Lorentz invariant. So, but we have already discussed Schrodinger wave equation, which we have already discussed, can't be is not Lorentz invariant. Why? Because we know that is not that can't be right in the form of the Lorentz scalar. Okay, but this field may be right in the form of, this field is called Lorentz scalar. Okay, so this field is a Lorentz scalar. This is a scalar field. Sometimes we say that is scalar. Actually, this is the Lorentz invariant term. Okay. Okay. Now, Schrodinger wave equation is not Lorentz invariant, so we have to replace Schrodinger wave equation with the equation which must be a Lorentz invariant. Nevertheless, we know that what we have in last lecture we have proved that P square P mu, P alpha and P alpha for momentum, that is Lorentz invariant in 4-vector form. The first lecture on advanced quantum mechanics, I have stated that P square is equal to P dash square. Yes, and that is equal to M naught square. Oh, sorry, that was the M naught square. Yes, M naught square. Yes. Okay. So this is a very simple. But what is the P alpha? P alpha is in contravariant form EP because this is a column, so that will be there. Here will be a transpose. Other is covariant. This will be a negative P, and this will be a E square minus P square, and that will be equal to M naught square. We have already proved that. Got it? Okay. This is also a Lorentz scaling. Okay, this equation is also a Lorentz. So you have P square minus P square, that is equal to M naught square. M naught is the rest mass. Okay. According to canonical quantization, E operator, when we quantize it, this will become a E operator square minus P operator square, that will be a M naught square after quantization. And from canonical quantization, QM1, okay, BS QM1, E operator is equal to iota curly by curly T. P operator is equal to minus iota curly by curly X. Okay. By putting these values in, so whenever you replace operator always apply on any solution. This will be applied on any state, as in the case of Schrodinger wave equation. Okay. When we replace it with the operator, then it will be applied on, operator will be always applied on any state. किसी पे apply होता है ना. So when we take minus iota square mean minus 1 minus yes, so this equation will become minus partial over partial T square. Okay, minus iota square, minus square is plus 1, iota square equal to minus 1. This will become plus, minus plus, iota square equal to minus 1, and minus plus. Okay. Yes. And this will are applying on state function. Okay. Yes. Now question is, this may also write in the form of, this is for a free particle, because I am not involving any this KG equation for free particle. Why? Because I am ignoring the potential term or any type of interaction. Okay, this is a free particle. Yes. Okay, if we multiply with the minus, this can maybe write as this may be right in this way. Yes. Okay. Yes. What is this? Oh, sorry, here I must write, because second component I always take as a, I must write, this is P. Okay, this P is a, okay. Okay, this is not 4 momentum, this is a 3 momentum. I have 4 momentum, this is the 4 momentum total E and minus. Okay. So this is, yes, the second equation में yes, yes, you are right. Okay, thank you for correction. Yes, okay, okay. What is this? This is the operator. Yes. No, this may be right as in form of the matrix this may write in this way. This will be equal to this. Eh? One will be plus, one will be a minus. It's up to, यहाँ भी minus लिख सकते हो, यहाँ भी लिख सकते हो. It's up to you. Okay? Yes? Okay. Yes. Row, both are positive. If both are positive in denominator, if both are positive in the numerator, they will be a contravariant. If both are negative in a denominator, then that will be a covariant. Yeah, you may say that this is partial over partial x alpha. अभी हम इसे contravariant में देख लेते हैं. x1 is t, x1 to 3 is this. Okay, and what is this? Alpha. Okay. This is, both are positive. This is contravariant. Both are positive. Negative. One is positive. One is negative. This is a covariant. Plus m naught square. That will be a 0. Yes. Okay. Got it? Okay. This equal to this. This is 0. Okay. In denominator, contravariant is covariant and covariant is contravariant. So first is, this is contravariant, so but it is in denominator, so it will be a covariant because this is contravariant in denominator and this will be a contravariant. And plus m naught square, this psi is 0. Yes? Okay? This is the Lorentz invariant term. Alpha is constructing with the alpha. M naught is scalar, is also a scalar. It is Westmark. It is Westmark. It don't transform under transformation. This is also a scalar. I have already explained it is also scalar. So all terms are a Lorentz invariant. Okay. Whole equation is a Lorentz scalar. Okay. So that will be not. Okay. So this field is defined as a Lorentz scalar field. Okay. We will discuss a different vector field and in upcoming lectures. Okay. This will be equal to 0. Okay. This is a KG equation. Okay. And where I have already discussed, this is equal to this. As we okay. By putting this value into this equation, okay, yes, I have already explained this is okay. Yes. This equation is called Kelvin-Gordon equation for free particle. Yes. Okay. Oh, sorry. There's one mistake. What is that mistake? Do you know? There is some mistake. Yes. Anyone? This is a Lorentz invariant term. This is also a Lorentz invariant term. And the indices must be a different. Okay. They must be a Lorentz scalar, so that must be a different. Okay. So that's means it's up to alpha is not. If you are interested to change these indices, you may change these indices, or you may change these indices. Okay. इसको कर बीटा कर लें. Must try. If वैसे तो ये ठीक है, लेकिन जब वैल्यू में आपने पुट करना है तो they must be a different. Okay. So it must be a beta or beta. Okay. So they must be a different. Non-indices comes 4 times beta. Okay. Yes. Okay. Psi m. What is this? This is contravariant. This must be a contravariant, means covariant. If it contravariant, then in denominator that will be a covariant. So this contravariant will be treated as a covariant. I may write in the form R. I may write say that that is transpose. Okay, it's your on choice. मेरा ख्याल है वो ज़्यादा बेहतर है, वही रख. Okay. So when we take derivative of exponential, power will be and x beta minus iota p beta, okay, e minus iota this will be come out. Okay. Yes. Derivative of x beta with x beta will be 1. Derivative of x beta with x beta will be 1, or and if x beta are different, then that will be a 0. Okay, means there will be a x beta over partial x alpha. Okay. Okay. And what is this? Minus iota p beta exponential of, or if you are interested to write in the form of e, minus iota p beta x beta. What is the derivative? Yes. Both are the same, then that will be a 1. X divided by x equal to 1. X divided x derivative of x with respect to y, that will be a this. So if both are same, then derivative will be 1. If they are different, then derivative will be a 0. But we don't know when they are the same. When they, so because both are possibilities. Because beta is 0, 1, 2, 3. मतलब t x y z, and alpha is also a 1, 2, 3, x, y, z. So all components must be included. Okay. So this will be a this function will be representing by that is the same is 1 and different is 0. That is the canonical delta. Okay. But must be careful. This x beta is covariant and this x alpha is contravariant. Yes? Alpha is contravariant because it is covariant under denominator, and beta is covariant in denominator. So this is canonical delta. Alpha is contravariant and beta is covariant. Yes. Okay. And this will be a IM. Beta will be actually okay. This term is Lorentz invariant term. This term is Lorentz invariant, so it must be maybe replaced with the any other term because both are contracting. So, as I have already explained, the mean indices may replace with any other indices because to avoid the misconfusion. Okay, got it? Got it? So, okay, this beta will be replaced. This beta is contracting with this beta. So this delta will. What is the function of canonical delta? It always change the indices of which are multiplying with this. Okay. So if I say yes, okay, got it? Yes. So this will be minus iota. Yes, P. What is the, and this is on the P. Beta beta contracting. This will be replaced with the alpha. E की power minus iota E gamma x gamma. Okay. So this equal to this. No, sorry. Okay. Minus iota P alpha. This is, what is this? What is this? This is xi. When we apply contravariant, it will give you a minus EP contravariant, P in contravariant form, and this will be equal to this. Okay. This will be equal to this. Okay. Got it? And if we consider covariant in a similarly way, we get a covariant in the form of covariant. Similarly, yes, psi alpha psi. Yes, this will be equal to, if it is covariant, this will be this. This will be equal to this. Okay? Here it is row element, then it will be converting to column. Here it is column, then it will be converting into the same. Actually, you may say that psi alpha psi is equal to minus iota p alpha psi. This and this. You got, we have gotten two equations, 1 and 2. Yes? Good? मुश्किल तो नहीं लग रहा? Okay. Okay. So you this, okay? Putting this in equation this. Put in 1 and 2 in equation x. This is equation x, KG equation. Yes. Yes. And you will put here, okay. Actually, this is this operator is applying on this, okay. So minus iota p alpha minus iota p alpha minus iota p alpha, okay. Plus m naught zero, please, okay. Minus 1 minus plus iota square minus 1. Okay. Yes. What is this? Yes, scalar. This is p square minus p square minus m naught square equal to psi equal to 0. This is minus e square plus p square. Yes. P is minus e square p square. Yes. Maybe it's difficult for you. sorry, no, minus p square minus if we multiply, if I multiply with the minus e square minus p square, it will become plus or p square minus, yes? If I multiply with the negative, this will become e square minus p square, this e square will become a plus m naught square. This will be equal to 0, 0 multiplied with minus, that is 0. So if both will go here, so this will be equal to this, and E will be a plus minus p square minus m naught square. So this is eigenvalue or eigenvalue solution, okay, and this is the eigenvalue of energy. So Kg equation gives two eigenvalues of the energy. One is related to positive and one is related to the negative. So it was a very surprising effect result. Energy may be a negative. You know that up till now we consider that in physics energy may only be positive. Negative, the concept of negative energy don't exist. Yes, ऐसा ही है ना, negative energy का कभी concept आपने नहीं सुना. You know that there is a positive energy, mean potential energy किस तरीके से increase हो सकती है या क्या, but negative energy, there is no negative energy concept. If there is a negative energy, if the negative energies exist, then the electron will be fall and because they goes to the down. The all positive energy electron will be fall into the negative energy, and there will be no limit of the negative energy. They will be fall, and continuous radiation will be emitted. So this concept is not acceptable. But later on it is explained by a different scientist. How that is interpreted, I will explain it now. But that is not only one problem in Kg equation. There is another problem that was about, this is physics in a period, not gaming period. Okay. One problem is that it is predicted that there exists a negative energy. And the second problem is that it is also predict negative energy, negative charge density, charge density. That is also not acceptable. Okay. Now I will prove that why one is that is negative energy and why other is the regarding negative charge density. Okay, what is how this equation is predicting the negative by equation of continuity. Okay. Firstly, we have to derive the equation of continuity. Okay. Because we are dealing in the four-dimensional momentum space, so we will write equation of continuity. Firstly, we will write the equation of continuity in four-dimensional space. Okay. We know that what is the equation of continuity? We know that I have already derived, please, equation of continuity are 4-dimensional, 4D space. What is the equation of continuity? Yes, I have already in KG equation. What was the that was partial rho over partial T. Yes. Partial rho over partial T plus del dot J equal to 0. This is the equation of continuity in 3-dimensional space. Okay. This may be right as this may be right in this way. Yes. Okay. So and yes, they may write in this way. This may write in this way. Yes. This multiply with this multiply plus this multiply with this multiply with this and this. Okay. Got it? I have write in the form of the matrix. This is row matrix, this is a column. Okay. Or in tensor form, X bar means X, Y, Z. Jx is this. Okay. Both are positive. This is X alpha. Yes. And this is J component. Both are positive. J alpha, where J alpha is rho and J. Okay. Okay. Yes. All are in column. I think J naught is rho and Jx, Jy, Jz is J. As I have, this J is same as like we have discussed in the Schrodinger wave equation. Okay. So, what is this If there is a contravariant in denominator, that will be a covariant. So this is covariant and this is the current density in 4 vector form. Okay. Equation of continuity for 4 dimensions. Yeah, you may also say that equation of continuity in covariant form. It's also called 4-dimensional form is also defined as a covariant form. Okay. So this is the expression for equation of continuity in covariant form. Okay, okay, got it? So this now equation of continuity equation of continuity for KG equation. Now we have to drive as we have done in the Schrodinger wave equation. क्या? Full form Kelvin-Gordon. Kelvin-Gordon equation. How we will find what we will repeat. This is a repeated procedure as we have did in the case of KG equation. Schrodinger wave equation. We will repeat the same process with this equation. Firstly, write the equation. What is the equation? KG equation. Yes. What was that? Curly mu. Yes. Plus m naught psi m naught square. Yes. This is equal to 0. This was KG equation. Okay. Yes. Okay. Okay, this is not A, this is gamma A. If right or not right, it means that is a Lorentz invariant. मतलब जरूरी नहीं है, वो इसका function है, ठीक है? And that's the function. Okay. So this is a KG equation. Okay. What we have did in the case of in the Schrodinger wave equation, we have taken the complex conjugate of it. Yes. And we take the complex conjugate. How we find the equation of continuity? I repeat it. Firstly, I write the equation, then I have taken the complex conjugate, then I have multiplied with the equation x with the this, and we will get this result. And then I multiply with this, and this we get this. And then we have subtracted the z2 from the z1, and we get this result. And this is the equation of continuity for KG equation, where J is given this. Okay. 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 This is the expression of J. Okay, that we have derived. If it comes. Okay. Okay. We have already derived this result. What is this? What is the result? Okay. This was yes. When it was covariant, what we have derived? Yes. Iota P alpha. Driving this when we are finding the solution, eigenvalue solution. Yes. 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 Minus iota P alpha psi. Minus iota P alpha psi. Yes. So when this will be equal to this, okay, because here will be a actually psi is psi m exponential of minus iota p mu x mu. Oh, sorry, x gamma, whatever you have, right? S gamma. So if this, if we take a minus negative, then this will become a plus complex conjugate. When we take a complex conjugate, this will be a psi m exponential of plus gamma. Okay. This minus iota will be converted into the plus. So that's why here is minus, here will be a no minus. Okay. If here is minus, here will be plus. Yes. Okay. So this, putting this result in this, when we multiply iota with iota, okay, when we multiply iota with iota, this iota square equal to minus 1, or this will be plus. Okay, so you have iota psi star, sorry, iota p, iota p alpha. This psi star will be multiplying with this. Okay. Here is again minus. Here is again minus. Minus minus J alpha will be equal to minus minus plus, and iota square is equal to minus 1. So plus so this if I say this is what is the name of this? Okay, J alpha will be equal to iota plus iota E alpha psi into psi star. Yes? Okay. 2 iota P alpha. Actually, this will be a J alpha because free indices will be same. Okay. Okay. If you are remove alpha here, then this will be like a this. Okay. माइनस क्यों आएगा? माइनस iota square equal to -1. Here this is a plus. Okay, and here this is star. Okay, so iota square equal to -1 and -1 is plus. Both will be plus. Okay, so this J alpha will be equal to 2 iota P alpha. What is the psi bar psi? Psi m star psi m exponential of 0, because the complex conjugate will be cancelled out. Okay, and the exponential 0 is equal to 1. So this J alpha will be 2 iota P alpha. This is a number. Psi m is a maximum value. Okay. J0. What is J0? J alpha is J0 and J I have already defined. That is a rho and that is a J. This is charge density, this is a current density. Yes? Rho is charge density, J is current density. Okay. So J0, which is rho, that is 2 iota P0 okay, and this charge density is equal to this charge density. P naught is, what is the P naught? P alpha is so P naught is okay. And what is J? J, matlab Ji. That is, this is, what is this? I have already charge density. I have in Schrodinger wave equation we have already defined. This is a charge density. What is this Ji? This is current density. Okay. And current density is equal to 2 iota T. All remaining component have T. Okay. This is current density. This is exponential for current density. We have to find these two relations. That is charge density, and this is current density for kg. Okay? Okay? Kelvin-Gordon equation. Now we have found charge density as well as the current density. Okay. So now question is here current density is directly proportional to here current density is current density is time-like component. Okay, is time, because this is not component. Okay, not is time-like component. And sorry, not current density, charge density. And time component will be always and J is space life component of 4. Okay. What is the important result? Actually, this is also very surprising. Rho is equal to 2 iota e. This is a positive number. Okay, this is number because here is a square, and this is a number, a constant amplitude. Okay, this is not variable. Okay, Cm implies that rho is directly proportional to E. So you get two results. Rho is positive for E is greater than 0 or positive number. Rho will be negative for E smaller than 0. Means if energies, there are two type of energy solutions. Have positive energy solution with positive charge density, negative energy solution with negative energy charge density. Now problem is that density must never, probability and density must never be a negative. Okay, so mostly scientists think that the KG equation is flopped, and we must move toward another equation, because we can't ignore this negative solution, because in quantum mechanics we know that we have already studied in quantum mechanics, a simple undergraduate level quantum mechanics, the set must be complete. Okay, all bases must be included, or completeness. So if we ignore this solution and we say that then that means that will be not a complete set. Okay, they will be not. So we can't ignore this this part. But there is no physical that is not acceptable for mostly scientists, because they were, how it is possible, what is the meaning? If an electron has a negative energy, then it will be fall and fall and fall and fall. If there is, they will be drop and drop and drop and drop, and finally radiation continues. Okay, and there is a negative charge density concept that is also not acceptable. Dirac actually removed this concept by considering a new equation. We will not go in the new equations. Only I'm just writing. Okay. Dirac used Dirac reject this equation, KG equation, that is right. Dirac used this equation. How it is derived, I will explain in the next lecture. Where x will not, he used that x naught will be not Lorentz scalar. That KG equation was a Lorentz scalar. Why this is not Lorentz scalar, we will discuss in the next lecture. Lorentz scalar, but this was not a Lorentz scalar, but spinor. God consider it as a spinor. But spinor, but Dirac spinor with spin equal to 1/2. So this was specially designed for a lepton. The KG equation has a no restriction on a spin. Okay, there was a no condition, but Dirac spinor has a condition about the. Okay, but in this case, but in Dirac equation, unfortunately, but in this equation, Dirac, D-I-R-A-C, but in Dirac equation, negative charge density problem has been solved. Means the solution of this equation, we will drive the, we will find the charge density, and we will prove that the charge density will be a positive. But negative energy solution still exists. So, according to Dirac, this new equation which we will drive and we will discuss in detail in next lecture. Rho is 1, rho is positive with E greater than 0. The second, he has proved that rho is positive, E negative. There are two. They have also two solutions, in a negative energy solution and positive energy solution. Okay, but he had interpreted this negative energy solution. Dirac interpreted negative energy solution by considering that negative energy solution by considering that, yes, what Rod has done, he considered that only 5 minutes, okay, just one, okay. What Rod has done, Rod said that there is some well, there is a two solution. This solution E is less than 0. This is E greater than 0. There are two types of okay. C. This negative C is vacuum. He said that is vacuum. Okay. And this is a vacuum. And this is filled with the negative energy solution, negative energy electron. And because Rod equation deal with the spin half particles, so all this negative energy solution, yeah, negative energy vacuum will be filled with the electron. An electron will obey the, that is completely filled, an electron will be completely filled with the, yes, but electron has a spin 1/2, so only 2 electrons will be that will obey the Pauli exclusive principle. He said that all the electrons occupying the negative energy C, okay, negative energy electron will follow the Pauli exclusive principle. If it is according to Pauli exclusive principle, if this C is filled, no electron may be entered into it. Because if that is not Pauli, if that is not electron, then they will be, if they don't follow the Pauli exclusive principle, the electron will be fall and fall and fall and fall. But he gives the solution that since these are only the electron, negative vacuum is filled with the negative energy electron, and they follow the Pauli exclusive principle. So no electron can enter into this C. So he said only possibility is that if we provide energy h cut omega, that is energy, we know that, okay. If the photon of the energy and this energy is equal to this difference, these has a mass m naught. Here is also electron that has a positive energy m naught, okay. So if this hit the electron, and then this electron will be jump into the upper positive energy level. That is the only possibility. Okay. If the electromagnetic, if the energy provided by electromagnetic form, and this will eject this electron to this energy difference, and that this energy difference will be equal to, because here this mass is यहाँ से electron remove हो गया और यहाँ चला गया. Rho will be positive. He solved the problem of the charge density. That will be a positive. Okay, but energy may be a positive or negative. So he explained what is the meaning of the negative energy. Okay, so here charge density is the positive, but energy still exists the negative energy. 1 minute. But I have to complete only this picture. Okay. Yes. Okay. Okay. So he said when it move upward, The condition is h cut omega must be greater than, because a hole is created, this is m naught energy, this is m. So this energy must be greater than or equal to 2 m naught. Okay. Okay. And here will be, when this electron will be jump into this, here will be hole. Yes, that is the Dirac hole. So, and hole. Okay. Hole have, yes. What is the mass? Mass will be equal to, the effective mass will be, have mass equal to mass of electron. Yes, because electron is leaving. Okay. Yes. And what will be the charge? And charge will be opposite to the charge of electron. What is that? Positive. That is that positive? Okay. So he stated that the electron, and this will be you may say that this is the like antiparticle. When electron will be jump into this hole, okay, this antiparticle or Dirac hole will be combined like an energy will be emitted when it will jump from, and when electron from positive energy will jump into this hole to fill this hole, then energy will release. This process is like pair creation and annihilation. Okay, so this was the idea of the Dirac. Okay, got it? I think for today it is enough. Okay, and next we will discuss about what was other possible interpretation. Okay.